Okay, let's unpack this. It is Tuesday, February 10th, 2026. And I want you to just picture something for a second. You're standing on a street corner in the South Bay, Los Angeles.
Okay.
Maybe you've got your coffee, the sun's coming out. But if you really look at what's happening around you, you're in the middle of what I'm calling a 20-hour microcosm.
A 20-hour microcosm. That is a very dramatic way to start a Tuesday.
It sounds dramatic, I know. But just stick with me. Because if you look at the data stack we pulled, and this is just from the last, 20 hours or so, you see this incredible collision.
Right.
Two completely different economic eras, happening on the same city block.
I see where you're going with this. It's the friction point.
Exactly. On one side of the street, you have let's call it the old guard, legacy auto parts companies, massive warehouses, forklifts everywhere.
Right. Logistics, storage, heavy metal.
But then, right across the street, you have this semiconductor explosion that is, and I mean this literally, too hot for a standard office building to handle.
And that is really the core of our story today. A tale of two neighbors. We are diving into a very specific and very expensive question. Will this huge hiring wave we're seeing at Navitas Semiconductor force them to build new, specialized lab space?
And spoiler alert for everyone listening, the answer is a resounding yes. But the reason why isn't just, more people need more desks. It's about physics. It's about 800-volt architecture and this pivot from making phone chargers to fueling the AI arms race.
It's a perfect storm where the engineering constraints are actually dictating the real estate deals. You just can't negotiate with physics.
So for this deep dive, we're pulling from a really interesting stack. We've got a forensic analysis from Voxel Micro Video Labs.
That one's focused on the commercial infrastructure.
Yep. Then there's a South Bay Economic Nexus report, some fresh financial data from Motorcar Parts of America, MPAA, and just to ground us in local reality, the agenda for the Redondo Beach City Council meeting for today.
Which, and you're going to love this, it actually connects back to the semiconductor industry in a very roundabout, pickleball-related way.
We will absolutely get to the pickleball. But let's start with a catalyst here, Navitas Semiconductor. They've launched this thing called Navitas 2.0. Now, usually when I hear a company slap 2.0 on something, got to roll my eyes. It's like, great, a new logo and maybe a software update.
This is definitely not a software update. This is a hardware revolution. This is about physical atoms and electrons. Just yesterday, Navitas put out the technical specs for a new 10 kilowatt DC to DC platform.
Okay, let's just pause on that.
Yeah.
10 kilowatts. For those of us who aren't electrical engineers, can you put that number in context?
Sure. Think about a standard space heater, the kind you might have under your desk. That's maybe 1.5 kilowatts.
Okay.
So we're talking about almost 7 times that level of energy density. And it's all packed into this tiny module. But more importantly, it operates on an 800-volt architecture.
800 volts. That is significantly more than the outlet in my wall.
Massive. And this matters because of who they're building it for. See, Navitas, they used to be known for those little fast chargers. For your phone, for your laptop, great tech, gallium nitride, very cool stuff. But that's consumer electronics. This new platform, this is for data centers, for AI.
The AI pivot.
Exactly. The bottleneck for AI right now isn't just about writing better code. It's not just finding more data. It's what we call the thermodynamics of intelligence.
The thermodynamics of intelligence. That sounds like the title of a sci-fi novel. I love it.
Well, it's a very messy and a very, very hot reality. When you train an AI model, you are pumping massive amounts of electricity into GPUs, into silicon, just to do math. And that generates an immense amount of heat.
So traditional silicon is kind of hitting its limit.
It's hitting a wall. It gets too hot. It's not efficient enough at those power levels. This is why Navitas is moving to these new materials we keep hearing about. Gallium nitride, or GoVN, and silicon carbide, SiLiT. These are what we call wide band gap semiconductors. I mean, without getting too deep into the quantum physics, it just means they can handle much higher voltages and switch power way faster than silicon without melting down. This new platform is 98.5% efficient.
Now, 98.5% sounds really good, but is it that much better than, say, 96%?
In a hyperscale data center. Oh, absolutely. When you are spending millions of dollars a month on your power bill, a 1 or 2% gain in efficiency is like finding free money. I mean, it is millions back to the bottom line. But there's a catch.
Okay.
To get that efficiency, you're cranking up the power density. You're cramming more and more energy into a smaller and smaller space.
Which brings us back to the hiring.
Yeah.
Navitas is pruning its consumer-focused roles.
Right.
They're not hiring salespeople to go pitch chargers to Best Buy anymore.
No. They are hiring highly specialized power electronics engineers, people who really understand high-voltage architecture.
And this is where that Voxel report just blew my mind. The analysts were so blunt. They said, and I'm quoting here, "You cannot test an 800-volt system in a cubicle."
It's a physical impossibility. I mean, I suppose you could try, but it would be an incredibly dangerous and very short experiment.
Dangerous how?
Well, if you take an 800-volt system with the kind of current these data centers use and you try to plug it into a standard office building, you're not just going to pop a breaker. You're looking at arc flash risks. You are looking at literally melting wires inside the walls. The Voxel report calls for hot labs.
Okay, define a hot lab for us.
Yeah.
Because I'm picturing a room with a soldering iron.
No, think much, much bigger. A hot lab for this kind of tech needs three-phase power coming into the building at industrial levels. You need massive cooling capacity, like industrial chillers on the roof, because you have to simulate the brutal heat of a data center to see if your chip survives.
So you're actually trying to create the heat on purpose. You're torture testing this hardware.
You have to. The energy density is 2.1 kilowatts per cubic inch. That is just unbelievably dense. If you don't have a specialized environment to dissipate all that thermal energy, you'd set off the fire suppression system in 5 minutes.
There was an analogy in our notes that I really liked. It's like trying to test a jet engine inside a library.
That's a pretty good way to put it. Your standard office park, even your typical flex warehouse space, it just doesn't have the bones for this. The floors aren't reinforced for heavy thermal chambers. And it definitely doesn't have the electromagnetic shielding.
Shielding, you mean like a Faraday cage?
Exactly. When you switch power that quickly, and these Navitas chips are incredibly fast, you create a ton of electromagnetic interference, EMI. If you don't shield that room, you could disrupt electronics in the building next door. You could wipe out a server. So you need a very controlled, very shielded environment.
So Navitas has a problem. They're hiring all these amazing engineers for Navitas 2.0, but they can't just stick them at a desk with a laptop.
That's the multi-million-dollar question for the South Bay real estate market right now. The Voxel report suggests Navitas really only has two choices. They can try to massively retrofit their headquarters in Torrance.
Which is expensive and disruptive.
Very. Or they have to go out and find new flex R&D space.
Flex R&D, is that the specific industry term for this?
It is. It's that sort of sweet spot between a polished office and a gritty factory. And right now, in February 2026, that kind of space is incredibly scarce.
Well, usually when space is scarce, companies hesitate. But we saw a pretty clear signal in the financial data that suggests Navitas is not hesitating at all. They just did a private placement.
$100 million.
$100 million. And the paper specifically says it's for R&D and manufacturing ramp-up.
In the semiconductor world, ramp-up is code. It's a paper trail. You don't raise $100 million just to pay salaries. I mean, they're high, but not that high. You raise that kind of capital to buy equipment, heavy equipment. Thermal chambers, power analyzers, automated test rigs.
And you need the square footage to house all of it.
Precisely. You can't buy the equipment if you don't have the floor space for it. You need a home for the $5 million machine that goes ping.
Now, looking at the market this morning, again, Tuesday, Feb 10th, Navitas stock, that's NVTS, it was trading pre-market around $9.04, maybe up to $9.22. It's been volatile.
It has. It was down about, 1.5% to 2% early on.
So why is that? If they just announced this amazing new tech, shouldn't investors be thrilled?
It's the tension between the future promise and the current cost. Investors love the idea of AI revenue. They absolutely hate CapEx, capital expenditure, and building these hot labs, buying all this machinery that burns through cash. The market is basically digesting the fact that Navitas is spending big to make this happen. They're betting the farm on this 800-volt strategy.
So that's the new guard expanding. Now, I want to pivot to that neighbor I mentioned, the old guard. Because in the same area, we have Motorcar Parts of America, MPAA, and their story is the complete opposite.
It really is. They reported their Q3 results yesterday, February 9th, and the headline, sales were down $17 million.
$17 million, that's a big hit.
It was mostly from one large customer cutting back orders. But for our purposes, the interesting part isn't the loss, it's the physical reaction to that loss. MPAA is consolidating. They are closing distribution centers. They are shedding square footage.
So we are watching a real-time handover of the local economy.
We really are. Just think about the physical footprint. You have a legacy company that stores car parts, logistics, warehousing, moving boxes, and they're shrinking. And right next door, you have a company that's engineering the backbone of AI, and they desperately need more space.
But not just more space, a completely different kind of space.
Exactly. You can't just move Navitas into the old brake pad warehouse and fire up the 800-volt testers. The infrastructure isn't there. You'd have to gut the whole building.
The South Bay report calls this the transition to an intellectual property hub.
And that's the key phrase. The value isn't in storing the thing anymore. The value is in designing the thing. And that changes everything for the city. It changes the tax base, the traffic patterns, and the buildings themselves.
Speaking of the city, let's zoom in on the municipal level, because we pulled the agenda for the Redondo Beach City Council meeting that's happening today.
And if you know how to read these things, the closed session is where the real action is.
Conference with real property negotiator. I'm counting. 5 or 6 different properties listed here.
It's a lot. They're negotiating on the International Boardwalk, the Marina parking lot, properties on Catalina Avenue.
What does that tell you?
It tells me that land is the most valuable currency in the South Bay right now. The city knows the usage of these commercial zones is changing. You have all these high-tech engineers coming in, and the city is trying to figure out how to leverage its real estate to fit this new economy.
Okay. I have to mention this one small detail from the agenda. It made me smile, but I think it actually fits your point perfectly. Item H6.
Oh, I had a feeling you'd bring that up. The pickleball.
The pickleball. They have an agreement to resurface the tennis courts at Alta Vista Park, but they're converting one of the tennis courts into 4 pickleball courts.
It's a great little detail, isn't it?
It's small, but it's the same theme, right?
It absolutely is. It's all about adapting existing infrastructure for new high-demand trends. Whether you're taking a warehouse and turning it into an 800-volt lab because of AI, or taking a tennis court and turning it into a pickleball complex, the principle is the same.
The old usage doesn't fit the current demand.
Exactly. You have to retrofit. You have to change the stripes on the court. And the South Bay is going through this massive retrofit from the parks all the way to the industrial parks.
It really paints a picture of a region just in complete flux.
Yeah, and it all comes back to that 10-kilowatt power module, because that little piece of hardware is dictating the reality on the ground. Navitas isn't just hiring people, they're hiring capabilities.
Right. They aren't just filling seats.
No. And you cannot house those capabilities in a standard room. If you're an investor or even just a resident driving past these buildings in Torrance, you have to look at them differently now.
How so?
You have to ask yourself, is that building just storing cardboard boxes? Or is it reinforced with extra steel and copper to test the future of AI? Because the outside might look exactly the same, but the inside is undergoing a radical transformation.
And the Voxel report was clear. If Navitas doesn't find or build this space, the hiring physically cannot happen. The Navitas 2.0 pivot just stalls.
That's the why from the beginning. The physics dictates the real estate. You can write code anywhere. You can write code in a coffee shop. You cannot test silicon carbide chips at 800 volts in a coffee shop.
Not unless you want to take out the espresso machine and the entire block's power grid with it.
Exactly. And that physical need for heavy power and heavy cooling is what's going to drive construction in this area for the next few years. It's not about more office towers. It's about these specialized hard tech environments.
So to bring it all home, we started with the question, will this hiring wave at Navitas require specialized lab space?
And the evidence from the tech specs, the $100 million raise, the forensic report, it all points to a definitive yes.
It's a fascinating moment for the South Bay. We're moving from the era of the mechanic to the era of the engineer, from the warehouse to the clean room.
And it's happening fast. If you look at the market volatility this morning, you can see Wall Street is trying to figure out who wins and who loses. But if you look at the construction permits and the real estate deals, the trend is clear. The infrastructure is being upgraded.
It leaves me with a pretty big question, though. We talk so much about the digital revolution. We think of AI as something that, lives in the cloud, like it's ethereal.
But the cloud has a physical address and a very, very high electric bill.
Exactly. We forget the cloud is made of metal and silicon. So here's my provocative thought for you to chew on. If the AI arms race relies so heavily on these physical, high-voltage labs, are we just vastly underestimating the real-world construction boom needed to support it?
I think we are. We focus on the chips, the NVIDIAs, the Navitas of the world, but we forget the buildings that have to house the chips. And if you don't build the labs, you don't get the AI. It might just be that simple. We could be bottlenecked by brick and mortar, not by silicon.
A sobering thought for anyone who thinks the digital world isn't tethered to the ground. Next time you're driving through Torrance, maybe take a second look at those industrial buildings.
You might just be driving past the engine room of the next decade.
Thanks for diving in with us. We'll catch you on the next one.
See you then.